Okay, on to the video for day 9 of our packet. Day 9 starts off with a rather convoluted question about system of equations. It says change the second equation so that the elimination method could be used to solve this system. And as you notice, the second equation starts with 5x up here, starts with negative 10x down here, which implies that they're taking the second equation and multiplying everything by negative 2. Meaning that they're looking for you to write negative 7 in the first blank and negative 24 in the second blank. And it says solve the system. Okay, well the whole point of doing this was to create a system that could be eliminated. So let's write what we've got here. The first equation is 8x plus 7y equals 10. The new second equation is negative 10x minus 7y equals negative 24. That is set up for elimination. If we add those equations together, 7y will cancel. And we will be left with negative 2x equals negative 14. Divide by negative 2. And we get x equals 7. Now, at this point, you all know that you're supposed to take that value and plug it back in for x in any of the 4 equations. So let's use the first one. 8 times 7 plus 7y equals 10. Now folks, this is where some of you are probably getting confused because these numbers are not great. We multiply 8 times 7, it's 56. We subtract 56 from each side of the equation, which gives us 7y equals negative 46. And then we divide by 7. But Mr. Wills, negative 46 is not divisible by 7. You're correct. Y is a fraction, negative 46 over 7. I've checked 3 times. That is the answer. So the correct answer to this system of equations is 7, negative 46 over 7, which is not really an ideal answer, but on the ISTEP, we don't expect anything to truly be ideal. Next up, we have volume of a cone. So we would go to our reference sheet and we would locate volume of a cone. Volume of a cone is V equals 1/3 pi r squared h, where r is the radius of the circle, so in this case r is 5 inches, and h is the vertical height of the cone, in this case 9 inches. And then we would go and we would plug these values into the volume for r, which is 5, and h. Now, there are actually 2 ways to present this answer, and you probably wouldn't have this question on the part where you have to provide a short answer. It would probably be a multiple choice. So I'm going to show you both potential answers for this so that you would recognize the difference between them on the test. The first one, if we were to use, if we don't plug in a value for pi, then this is 1/3 times pi times 25 times 9. 1/3 times 9 is 3, so that means that the volume is equal to exactly 75 pi cubic inches. Now, that's one possibility, is they could give you the answer with pi in it. The other is that they could give you a decimal approximation, which would be 235 about 0.62 cubic inches. It just depends on whether or not they put in a value for pi. So really it could be either answer, and we need to be aware that both exist. Okay? Number 3 deals with exponent rules, as does number 4. That's why they're on the same slide. There's actually 2 ways to approach this problem. It doesn't matter whether you divide first and then apply the exponent, or if you apply the exponent first and then divide. In the interest of keeping the numbers small, I'm going to divide first. 12 divided by 6 is 2. K over k to the 4th would be k to the 3rd. And then that value is going to be squared. Well, 2 squared over k to the 6th, which would be 4 over k to the 6th power. On number 4, we have to be very careful. A to the 0, anything to the 0 is equal to 1. So I would start by combining these two things. That would be 4a to the 4th raised to the 3rd, which would be 4 to the 3rd power a to the 4 times 3, or 12th power, which would be 64a to the 12th. Again, there are a number of exponent rules. We had a few of them in an earlier video. You need to make sure that you're aware of how to raise an exponent to a power and how to multiply and add exponents. All right, that brings us to the last problem on the Day 9 worksheet, which is a statistics question about sampling and biased. It says you want to estimate the number of students in a high school who ride the school bus. Which sample would give you the best data? So there's basically two things that can influence whether or not a sample is a good sample. The first of those two things is the size of the sample. Think about Speedway High School. It's not a very big high school, but it has 500 students. So if you're going to go try to figure this out and you want to know how many kids ride the bus, you should be pretty confident in saying that 4 students is too small of a sample. So A is definitely not the correct answer. So we should use our answer eliminator. Okay? Now, that leaves 3 answers that could potentially be correct, all of which have the other bias to consider. So the first bias could be sample size. You need to have a decently large sample. The second thing you want to do is you want to pick a group of students that is a good representation of the entire student body, not just a portion of it. So for instance, only looking at the marching band, that's too specific. And 50 seniors, that's too specific as well, because those kids are all old enough to drive. Which means a proportionally large group of them will probably drive themselves to school. So by far the best answer for this question would be the 100 students at random at lunch in the cafeteria, because there you're going to get freshmen through seniors, and you are going to get a large enough portion of the population to accurately estimate the sample. That does it for Day 9.